Hello, how are you friends? Okay, so today we are going to discuss about a new data structure. That data structure is called linked list. Okay, in the last class we have discussed about two different data structures that are stack and queue, and there we have used array. Okay, but in case of array we have some limitations. So, to overcome those limitations we are going to use this particular data structure, that is linked list. Okay. So, what are these limitations? So, in case of array it is static. Why it is called static? Static means whenever we are allocating some memory space in the load time, when program is going to load from secondary storage to primary storage. So, at the load time all the variables or all the memories which is required or which are required, they will be allocated inside main memory, and that is called static. In the runtime we can't change it. So, that we cannot be easily extend or reduce to fit the data set. Say for example, I have, say for example, we have allocated some memory space like int x of 20. So, 20 of size integer, if I consider integer at 2 byte. So, 2 into 20, that is 40 byte memory space will be allocated at the load time. Load time is what? Say for example, this is our secondary storage and this is our primary storage. So, whenever say for example, this is our program, whenever we are going to execute this program will occupy some memory space, and the what are the memory space will be occupied? The variables, the variable that we have declared it. Okay. So, for this only 40 bytes of memory space will be allocated. That means, there we can able to store same type of value, that those are of integer type, or that is of 20 numbers. So, we can't, but in the runtime if we need to store more values in the runtime, so we can't store it. If we want to store, say for example 25, so we can't do it, only we can able to store 20 values. The same way, if this 20 size is not required, at the runtime we are going to store only 10 values. So, 10 memory space will be wastage. So, this is the problem in case of array. Then another thing, it is very expensive to maintain for new insertion or deletion. Whenever we are trying to insert some new element and delete some element from that particular array. Say for example, I have an array like this, and which is having some elements like 3, 9, 2, 21, 32, 78. If I want to enter an element here at this particular place, then what we need to do? We have to shift all those elements, and that is very much expensive. At the same way, in the time of deletion also, if I want to delete this particular element, so this place will be blank, we must be shift all the right side element at this particular place. So, that is very difficult. Okay. So, to overcome these limitations of array, we have a new data structure that is called linked list, and where what we perform at the runtime, if we require a memory space, if we need a memory to allocate some value, if we want to store some value, we will allocate some memory space, and according to that we will allocate the space and we will store that value. So, what is linked list actually? Linked list is a dynamic data structure. Why it is dynamic? Dynamic means at the runtime, the static means in the whenever we are going to as it is predefined, that is called static, you can think about that way, and dynamic means whenever the program is executing, the program is running, in that time we are trying to allocate some memory space, that is called dynamic. Okay. Now, grow and shrink on demand. If we want to grow the number of elements in the list. So, for example, I want to store 100 elements, 1000 elements, more and more, any number of elements we can able to insert until unless we have the memory space available. Till the memory space available or memory space is full, that time, till that time we can able to store those elements. So, it can grow or shrink, we can delete the elements. So, automatically the elements will be deleted. How it looks like? Why it is called linked list? Because in case of linked list, so these are called, say for example, look here, this is say for example, this is an element. Okay, this element having this is a place, where we have stored 7 value, and another value. This value is nothing but the address of another value. So, this is another location, this is another location. So, these are nothing but some different locations having some different values. Okay. Here 7 is there, here 3 is there, here 20 is there. Okay. Now, here 2003, 8000 and null. So, what is this? So, there is a variable named as head, you can give any name. So, head is holding just the base address of this location, and this location is named as node. Okay. So, this location is named as node. Okay. And everyone is named as node. So, this I have allocated some memory space and I have stored the base address of this location, and then what will happen? So, by this is pointing this particular location. Again I want to allocate some memory space, that will be allocated, and the base address of this location 2003 is stored here, and by that way it is locating this location. So, this way all the nodes are linked together, and that is the reason why the name is given as linked list. Let us have an example, let us have more clarity on this by implementing this one. So, here we have, say for example, initially I want to or we want to store some element. So, what we will do? We will allocate some memory space. Say for example, I have allocated a memory space, and that memory place is allocated at 7000 memory location, 7000 memory location. Now, I have allocated stored some value, I want to store 30 value here. I have stored it. Again I want to store some new value. Say for example, that memory is allocated, the space will be allocated at 5003 location. So, what I will do? I will store the value here. Say for example, I want to store 12 here, I want to store 12 in our memory. Now, I have 12, I have stored, and this base address I will store in this place by help of 5003 I have stored here. So, by this what will happen? As this is storing the address of this one, as we know the pointer. Okay, by help of pointer, by help of referencing, we are referring this particular location. And this way, if we again want to allocate some new place, say for example, I have want to store 70 value in some memory space. So, what we will do? So, assuming this memory this space is allocated at a new location, that location is 9000, and here we have stored 70, and what we will do? We will store 9000 here, and this way we will continue. Again I want to store some value, so I will allocate some memory space dynamically. So, say for example, I want to store 80 value. So, this variable is allocated at 7005 location. Any random address, any location these values are stored. So, at 7005 location this variable is stored. So, what will happen? I will store 7005 here, and this will point this particular location, and if something is not there, I will store here null, and I will store the starting node at node's address at some variable. Say for example, I am using some variable named as h is storing 7000. So, by this what is happening actually? By this what is happening actually? We are trying to store some new value, and the runtime we are allocating a memory space, we are storing the value and linking with the previous one. How we are linking? By help of storing the base address of that location with the in the previous whatever node is there. Okay. So, everything here, this is called a node, this is called a node, this is also a node, this is called a node, this is called a node, this is called a node. So, each node having two different parts, one part is storing the value, another part is storing the address of another node. Okay. So, this part, the node, this part of this node is storing the value, and another part is storing the address of the next location. And here head is not a node, it is a variable, it is a pointer variable of the same type, and but it is storing the first address of that location. Okay. Let us have an example, and let us have the implementation of this linked list. So, first what we are going to do? First we are trying to allocate some memory space. So, we are trying to create a structure. So, this structure will we want to create a structure or node like this. So, where there will be two different places, one place is named as value, we can give any name, and another place is named as address ADD. So, I am creating here a structure struct struct L link. Okay. So, L link or otherwise I can just giving it as a single linked. Okay. I will discuss it later why I am using it the single link. Okay. I am just sake of you just remember this thing. Okay. I will discuss it later. Okay. I have used a name that is S link, and variable name I am using int VAL, and another one is pointer address ADD. Okay. So, what is the data type of this one ADD? The data type of this one, yes, it is struct struct slink. It will not be int. Those who are saying this is int, this is wrong, because the pointer variable, the type of a pointer variable will be the same type whose value or for which it is pointing, or it is pointing for a particular, or it is going to store the address of another structure of same type. So, sometime in interview the question is common question is asked, what is self referential structure in case of this structure. So, this particular structure is storing the address of same type of thing, that is called, that is why it is called self referential structure.